Games. They are the source to hours of fun and entertainment. But have you ever wondered what actually makes the game work? And I'm not just talking about the complicated code people spend years writing. I'm talking about, say, how the game knows how to push an object, what direction it's going, how fast it's going, how far it should go. Well, in most games, motion is generally created by something called forces. If you don't know what a force is, don't worry. It's basically a push or pull that, well, creates motion. Regardless on whether or not you have taken physics, you have most likely either seen or heard of the equation F equals ma. Well, F is the force, m is the mass of the object, and a is the acceleration of the object. Unlike the real world where objects just fall or balls are just thrown, to a computer, forces is just a number. It must translate these forces into motion before it can actually move the object. This basically means going from force to linear and angular velocity and displacement. But how can this be done? To start off, we need to understand the relationship between force and velocity and displacement. Well, force is equal to mass times acceleration, so we know the mass, we know the force, so we know acceleration. Now, quickly take a look at this graph. Notice at this point it has a slope. This slope is known as the derivative. For some functions like this, the slope is changing as it moves along the graph. Going back to acceleration, velocity, and position, the derivative of position is velocity, and the derivative of velocity is acceleration. Like many things in math, there is an inverse. For derivatives, this inverse is called the integral. It is comparable to multiplication. The inverse of multiplication is division. In the same sense, when we integrate something, we are finding the original function from the slopes. Computers basically take this acceleration and integrate to find velocity. They then integrate the velocity to find the position. Now, what is Euler's method? Great question. Well, here it is. It's actually a lot simpler than it looks, and even simpler to understand. For any use of Euler's method, one must at least know the derivative of the function and at least one point on the original function. Euler's method basically approximates the integral of a function at a specific point by using the derivative. We can calculate the slope at where x equals 0, and from that we can find the tangent line of the original function. We can then find the value a little further on that tangent line, and that is our approximation. This little distance we moved is known as the step size. Notice how if I show you the original function, it is a little off from the tangent line. That is why it's an approximation. Now, why can't we find the exact value? Why do we have to use an approximation? Well, in physics simulation, and especially games, there are tons of collisions going on, and this makes equations way more complicated and increasingly more difficult to find the actual integral. But Euler's method is not the only method of approximation, and it is not even close to being the most accurate. But it is fast and reliable. That is why it's good for games. On the other hand, for complex physics simulations such as fluid or air simulations, a similarly complex method may be used.
Wait.